This is the EdExcel GCSE 9-1 Maths Foundation Paper 2 from the June 2018 series, and this paper is a calculated paper. Question number 1, we have to write 4/50 as a percentage. Well, percentage means out of 100. So, if we have 4 out of 50, to convert this into a percentage, we want the denominator to be 100. And you can see, if I multiply the bottom by 2, I would also have to multiply the top by 2, leaving me with 8/100. This is equivalent to 8%. Question number 2, we have to write 1.59 correct to one decimal place. Well, here is a number line. 1.59 is in between 1.5 and 1.6, and we've got our halfway point, 1.55. Now, our number 1.59 is over here somewhere. And because the 1.59 is greater than the 1.55, we would have to round up. So we have 1.6. Question number 3, we have to work out the value of 3 to the power of 5. We have 3 to the power of 5, that's equal to 243. Question number 4, we have to write down a 6-digit number that has 4 as its thousands digit. You can only use the digit 4 once. So if it has 4 as its thousands digit, here is a 6-digit number. 4 is in the thousands column, and with the rest we can fill in any number apart from 4 because we can only use the 4 once. For example, we could have a 2 here, a 5 here, the 4's already been used up, a 1 here, a 3 here, and a 0 here. This is an example of a 6-digit number that has 4 as its thousands digit. So we have 2, 5, 4, 1, 3, 0 as an example of a number we could write down. Question number 5, for part A we have to change 35 centimeters to millimeters. Well, to go from centimeters to millimeters, we multiply by 10, and millimeters to centimeters we divide by 10. And therefore, we have 35 multiplied by 10, which is 350. For part B, we have to change 7,700 milliliters to liters. To go from milliliters to liters, we divide by 1,000. Liters to milliliters, we multiply by 1,000. So, we do 7,700 divided by 1,000, and it turns out we get 7.7 liters. For part C, we have to change 0.32 kilograms to grams. To go from kilograms to grams, we multiply by 1000, grams to kilograms, we would divide by 1000. And therefore we have 0.32 multiplied by 1000, which is 320. So we have 320 grams. Question number 6. Margaret is thinking of a number. She says, my number is odd. It is a factor of 36 and a multiple of 3. There are two possible numbers Margaret can be thinking of. Write down these two numbers. So the factors of 36, we've got 1 multiplied by 36, 2 times by 18, 3 times by 12, then we have 4 times by 9, and then we have 6 squared. Here are the factors of 36. If we write down the multiples of 3, we've got 3, 6, 9, 12, 15, 18, 21, 24, and so on. Now, our number is odd, and it is both a factor of 36 and a multiple of 3. So the numbers we could have, well, the 3 is odd and belongs to two categories. The 9 is odd and it belongs to both categories. So we could have the 3, and we could also have the 9. Question number 7. Mohsin, Yusuf and Luke are going to play a game. At the end of the game, one of them will be in first place, one of them will be in second place, and one of them will be in third place. We have to use the table below to list all the possible outcomes of the game. Well, we could have M first, Y second, and L third, or we could have M first, L second, and Y third. Or we could have Y first, M second, L third, or Y first, L second, M third. Or we could have L first, M second, Y third, or L first, Y second, and M third. Question number 8. Neil buys 30 pens, 30 pencils, 30 rulers, and 30 pencil cases. We have to find out what is the total amount of money Neil spends now. Here's a price list. With pens we get 6 pens for 82 pence, 15 rulers for 45 pence, 10 rulers for £1.25, and pencil cases are 37 pence each. So in this question we need to recognise we want 30 of each item. So let's first of all take a look at pens. With pens, we know 6 pens is equal to 0.82, and what we need to do is find out how much 30 pence will cost. So multiplying both sides by 5, we have 0.82 times 5, which is £4.10. Now let's take a look at the pencils. With the pencils, we know that 15 of them, this would cost 45p each, or in other words, £0.45. So 30 of them this will equal, well, what I need to do here is multiply by 2. So I get £0.90 or 90 pence. If we take a look at the rulers, then we know that we get 10 rulers for £1.25. So for 30 rulers, what we would have to do is multiply by 3. So what we end up with is £3.75. And if we take a look at the pencil cases, we know that one case is 37p. So for 30 cases, we have to multiply through by 30. And if we do that, we get £11.10. And therefore, for the total cost, we've got £4.10 plus 90 pence plus £3.75 plus £11.10. So if we work this out, we get £19.85. Question number 9. Emily drives 186 miles in 3 hours. What is her average speed? The average speed, that's equal to 186 miles, and then we need to divide this by 3 hours. And working this out, what we will end up with is 62 miles per hour. Then for part B, Sarah drives at an average speed of 58 miles per hour for 4 hours. How many miles does Sarah drive? So, the distance, that's equal to 58 miles per hour multiplied by 4 hours. 58 times 4 is 232. So we have 232 miles. Question number 10 for part A, we have to write down all the prime numbers between 20 and 30. Well, a prime number is a number which can only be divided by itself and 1 only. So if I write out the numbers between 20 and 30 inclusive, we've got 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. And what we want are prime numbers. 23 is prime and 29 is prime. We can't have any even numbers because they can be divided by 2. So the only numbers we could have will be 23 and 29. And then for part B, Catherine says 2 is the only even prime number. Is Catherine right? You must give a reason for your answer. 2 has factors of 1 in itself only, so it's got factors of 1 and 2. So it is a prime number, so she's correct. So which means 2 is the only even prime number. Question number 11 for part A, we have to solve x plus x plus x equals 51. Well, in total here, x plus x plus x, that's 3x. So 3x is equal to 51. And now if we divide both sides by 3, what we end up with is x equals 51 divided by 3, which is 17. X is 17. For part B, we have y over 4 equals 3. Well, if I multiply both sides by 4, then we will end up with y equals 3 times 4, which is 12. For part C, we have to solve 2f plus 7 equals 18. Well, if we subtract 7 from both sides, we will be left with 2f equals 11. And now if we divide both sides by 2, what we will end up with is f equals 5.5. Question number 12. A group of football fans were asked what their half-time snack was. The table below gives information about their answers. So 11 said burger, 17 said pie, 8 said hot dog. We have to draw an accurate pie chart for this information. Now what we need to do this question is find the missing angle. So if we think about how to find the angle, what we need to recognize is we have a proportion of the angles around a point. Now angles around a point sum to 360 and we have some sort of a fraction of that. Now altogether we've got 11 plus 17 plus 8, which is 36 fans in total. And of these 36, 11 like burger, so the angle represented by burger is 110 degrees. The angle represented by pie, that's 17. Rather, 17 people like pie, so the angle represented by pie, 17 over 36 times 360. That's 170. And for hot dog, 8 over 36 times 360, that's 80. So we have 80 degrees. So if we draw a pie chart for this, well, we need to show 110 degrees. So 110 that will be over here. So we join this up with this. We have burgers 110 degrees. Now for pie we have 170. So if I show that, well, for hot dog we have 80, so 80 degrees, that is over here. So join this up with this. And what we can see here then is we have hot dog at 80 degrees, and the rest will be pies. This will be at 170 degrees. Question number 13. A scout group has a raffle to raise money for charity. There's one prize to be won in the raffle. Laura buys 12 raffle tickets. A total of 350 raffle tickets are sold. We have to find the probability that Laura does not win the prize. So the probability that Laura wins, that's equal to 12 divided by 350, and therefore the probability that she does not win, that's equal to 1 subtract 12 over 350, which is equal to, well, if I work this out, we've got 1 subtract 12 over 350, which is 169 over 175. Question number 14. Each worker in a factory is either left-handed or right-handed. 22 of the 45 workers are male. 16 of the 34 right-handed workers are female. We have to complete the frequency tree for this information. Well, we've got 45 people in total, and what we know is 22 of these are male. So we've got 22 who are male, and we know that 16 of the 34 are female who are right-handed. So we have 16 right-handed female workers. So 16 would go here. We can use this information to fill in the missing boxes. What we have first of all is 45 take away 22, which is 23. So we've got 23 who are female. And then if I do 23 take away 16, we get 7. 7 are left-handed. And we know in total we've got 34 who are right-handed. So 34 take away 16, that's 18. 18 right-handed, which means 22 take away 18, that's 4. 4 left-handed. Here is the completed frequency tree. Question number 15. Mary needs to work out the size of the angle marked X in this diagram, she writes x is 63 because base angles of an isosceles triangle are equal. Mary is wrong, we have to explain why. First of all, we see that AC is equal to BC, which means that the triangle ABC is isosceles. That bit she got correct. And that means that the angle CAB is equal to the angle CBA, which is 63 degrees. So these are the base angles. And so therefore x is equal to 180 subtract 63 subtract another 63, which is 54. And that's because angles in a triangle sum to 180. So that's why she's wrong. Now William needs to work out the size of angle Y in this diagram. William writes, the angle EGH is 57 degrees because corresponding angles are equal, so Y is equal to 180 subtract 57, which is 123. Because angles on a straight line are up to 180. One of William's reasons is wrong. We have to write down the correct reason. So first of all, the angle EGH, that's this angle here, is 57. I agree with that. This angle here is 57. And the reason for that is, well, it's not because of corresponding angles. It's actually because we have alternate angles. So what we would put instead is EGH is 57 because we have alternate angles which are equal. Question number 16. Marla buys some bags of buttons. There are 19 buttons or 20 buttons or 21 buttons or 22 buttons in each bag. The table gives some information about the number of buttons in each bag. The total number of buttons is 320 and we have to complete the table. Well, in total we are told that we have 320 buttons. So the total number of buttons is given by 320. What we need to do is find the frequency when we have 19 buttons. Now, what we can do to find this total of 320, we can multiply the number of buttons by the frequency and then add them all together. So, to begin with, we will let the frequency of 19 buttons equal x. And so 19 multiplied by x, we have 19x. 20 times by 7, that's 140. 21 times 3, that's 63. 22 times 1, that's 22. Adding these together, we have 19x plus 140 plus 63 plus 22 equals 320. So, simplifying, we have 19x plus, now here we have 140 plus 63 plus 22, that's 225. This is equal to 320. And now if we subtract 225 from both sides, we would then see 19x is equal to 95. And now if we divide both sides by 19, what we will end up with is 5. So x is equal to 5. So when we complete the table, we can write over here the frequency for 19 buttons is 5. Question number 17. Here is a list of ingredients for making 30 biscuits. 225 grams of butter, 110 grams casting sugar, 275 grams plain flour, 75 grams of chocolate chips. Lucas has the following ingredients: 900 grams of butter, 1000 grams of casting sugar, 1000 grams of plain flour, 225 grams of chocolate chips. What is the greatest number of biscuits Lucas can make? You must show you're working. So for what we can do is find out how much of each ingredient we have for one biscuit. And to find out how much of each ingredient we have for one biscuit, what we need to do is divide each of these by 30. So we've got 225 divided by 30, which is 7.5 grams, and this is for butter. Then if I do 110 divided by 30, that will be 3.6 etc. grams, and this is for the caster sugar. If I do 275 divided by 30, we get 9.16 etc. grams. This is for the flour. And if I do 75 divided by 30, we get 2.5 grams of chocolate chips. Now, why is this important? Well, what we can do is divide each of these quantities by the relevant amount for each ingredient for one biscuit, and that will tell us how much of each biscuit we can make and what we're limited by. So if we take a look at butter, that means I need to do 900 divided by the 7.5. So if I work this out, 900 divided by 7.5 is 120. If I take a look at the casting sugar, we've got 1000 divided by the 3.6 etc. So that was 110 divided by 30, and if I do 1000 divided by this, we get 272 approximately. And if we take a look at the flour, then we have 1000 divided by the 9.16 etc. So if I work out the amount here, well, to work that out, I need to do 1000 divided by 275 over 30, which is 109. And then if I do for the chocolate chips, if I do 225 divided by 2.5, we get 90. So when we come to find out the greatest number of biscuits Lucas can make, of course that will be 90. So we have 90. Question number 18. We've got shapes A and B, and what we have to do is describe fully the single transformation that maps shape A onto shape B. Well, what we are doing is we are reflecting this shape in this line x equals 0. In other words, we have a reflection in the y-axis. Question number 19. A farmer has a field in the shape of a semicircle of diameter 50 meters. The farmer asks Jim to build a fence around the edge of the field. Jim tells him how much it will cost. The total cost is £29.86 per square metre of fence plus £180 for each day's work. Jim takes 3 days to build the fence. We have to work out the total cost. Well, what we need to do is find out the total perimeter of the shape. So the perimeter will equal then, well, I've got this 50 meters, but then what I need to do is add on the curved section over here. Now this is half of a circumference. Now to work out the area, rather to work out the length of the circumference, we multiply pi by the diameter, which in this case is 50. But then because we've got a semicircle, I need to divide through by 2. So let's work this out. 50 plus pi multiplied by 50 divided by 2. It turns out we have 128.5 etc. meters as our perimeter. So now when we come to work out the total cost, we know per meter it's 29.86 per meter, and then I multiply this by 128.5 etc. and then I add on 3 times by, because I'm working for 3 days, 180, because it cost £180 per day. So if we work out what this is, I'm going to times this by 29.86, and then I'm going to add on 3 times 180, and so to 2 decimal places we end up with 4,378.20, and this is to 2 decimal places. The reason we need to give it to 2 decimal places is because we are considering money, and so we have 4,378.20. Question number 20. We have to simplify m to the power of 3 multiplied by m to the power of 4. When we have the same base and we are multiplying, we add the powers. And so we have m to the power of 3 plus 4, which is equivalent to m to the power of 7. For part B, we have to simplify 5np cubed, all cubed. Well, what this is the same as is multiplying 5np cubed by itself 3 times. So 5 times 5 times 5, that's 125. N times n times n, that's n cubed. P cubed times p cubed times p cubed, that's p to the power of 9. So we have 125 n cubed p to the 9. And then for part C, we have to simplify 32q to the 9 r to the 4 divided by 4q cubed times r. Now r is the same as r to the 1, and the reason I'm writing this as r to the 1, well, 32 divided by 4, that's 8, and then we subtract the powers when we're dividing with the same base. Q to the 9 subtract 3, that's the same as q to the 6, And then r to the 4 subtract 1, that's r cubed. So we have 8q to the 6 r cubed. Question number 21 for part A. We have to find the lowest common multiple of 40 and 56. So let's think about this 40. Two numbers which multiply to give 40, one of them being a prime number. We have 2 and 20. Two numbers which multiply to give 20, one of them being a prime number. We have 2 and 10 we can further split up into 2 and 5. Now if I think about the 56, two numbers which multiply to give 56, we've got 2 and 28. 28 we can further split up as 2 times by 14, and 14 we can split up as 2 times by 7. And so therefore the lowest common multiple, what we have, which is common to both, we've got the 2, which is common to both. We've got this 2, which is common to both. We've got this 2, which is common to both. And then we've got the 5 and the 7, and all this needs to be multiplied. So what we end up with over here is 280. Then we are given that a is equal to 2 times 2 cubed times 3 times 5, and b is equal to 2 squared times 3 times 5 squared. We have to write down the highest common factor of a and b. So a, let's rewrite that as 2 times 2 times 2 times 3 times 5, and b, let's write that as 2 times 2 times 3 times 5 times 5. So for the highest common factor then, we've got the 2, which is common to both. We've got this 2, which is common to both. We've got this 3, which is common to both. And then we've got the 5, which is common to both. And now if we multiply these together, we get 60. Question number 22. The line L is shown on the grid as we see here, and we have to find an equation for L. Now we've got an equation of a straight line, and equations of straight lines, those are of the form y equals mx plus c, and m over here is the gradient, so m would represent the gradient, and the gradient is defined by the change in y over the change in x, and the c over here would represent the y intercept. So let's think about how we find the gradient. If I pick any 2 points, for example this point and this point, how many do we go across by? Well, that's just 1. And how many do I go up by? Well, that's 3. So the gradient in this case is equal to 3 divided by 1, which is 3. So the gradient is 3. And the y-intercept is where it crosses the y-axis when x is 0. That's minus 6. So when we come to find the equation of the straight line, we have y equals 3x minus the 6. Question number 23. Rhea buys a van for £8,500 plus VAT at 20%. Rhea pays a deposit for the van. She then pays the rest of the cost in 12 equal payments of £531.25 each month. We have to find the ratio of the deposit Rhea pays to the total of the 12 equal payments. Give your answer in simplest form. Well, in the first year, so let's write this down in year 1, what we have is 531.25, and then we multiply this by 12 because we are paying this into we are paying installments of this amount each month. So we end up with 6,375. So what does this number represent? Well, it represents the total of the 12 equal payments. So what we can do is find out the cost of the van as well. So the cost of the van, this is including VAT. Well, we've got the VAT charge, which is 20% of 8,500. So if I work this out, we have 1,700. So the total that's equal to the 8,500 plus the 1,700, which is 10,200. So what we can do now is find out the deposits. So the deposit is equal to 10,200 subtract 6,375, which is 3,825. So therefore the ratio of the deposit to the total, that's equal to 3,825 to 6,375. And I can simplify this ratio. If I look at the final two digits, here I've got 25 and here I've got 75. So I can simplify even further by dividing both sides by 25 to begin with. So if I do 3,825 divided by 25, we get 153. 2, and here I've got 6,375 divided by 25, which is 225. And now I can divide through by 51. So here, if I divide through by 51, I get 5, and here I get 3. So the ratio in simplest form is 3 to 5. Question number 24. For part A, we have to complete the table of values for y equals x squared subtract x subtract 6. Now, if we use our calculator, we can go to the table menu, and if I type in the function x squared subtract x subtract 6, we are starting at -3, we are finishing at 3, steps in 1. So when x is -3, y is 6, then here we've got 0, -4, -6, then here we've got -6, then here we've got -4, and then here we've got 0. So now that we've created a table of values, what we need to do for part B is draw this graph for -3 to 3. So here is our sketch. Then for part C of the question, we have to use our graph to find estimates of the solutions to the equation x squared subtract x subtract 6 equals -2. So what we'll do to begin with is we'll draw the line y equals -2. So if I do that, we've got the line here, y equals -2. And then what we do is we read up from where it intersects the graph. So it intersects here at minus 2.5 and also here at 2.5. So when we come to read our solutions, we've got x equals, rather here we've got minus 1.5 and then we've also got the 2.5. Question number 25. A force of 70 newtons acts on an area of 20 centimeters squared. The force is increased by 10 newtons, the area is increased by 10 centimeters squared. Helen says the pressure decreases by less than 20%. Is Helen correct? You must show how you get your answer. Well, we've been given that pressure is equal to force over area. So, before the increase, the pressure is equal to 70 newtons divided by 20 centimeters squared. So it turns out we get 3.5 newtons per centimeters squared. After the increase, the pressure P is equal to, well, what's happening this time is we're increasing the force by 10. So I've got 70 so far, and then I need to add on to this 10. And the reason for that is the force is increased by 10 newtons, which is why I add this 10 on. And then we divide by, well, I've got 20, but then I need to add on 10. And the reason I add on the 10 is the area is increased by 10 centimeters squared. And don't forget the units, newtons per centimeter squared. So it turns out we get 8 over 3, which is, if I work this out, 8 divided by 3, that is, as a decimal, 2.6, etc. newtons per centimeters squared. And so what we need to do in this question is find the percentage change. So the percentage change, well, we've got the difference, which is 3.5 subtract 2.6, etc. But then I divide by my original, which is 3.5, and then because it's a percentage, times by 100. So we have 3.5 subtract this divided by 3.5 times 100. It turns out we get 23.809, etc. %. And this value is greater than the 20% which Helen mentioned, so it increases by more than 20%. So in other words, Helen is incorrect. Question number 26. Here is a triangular prism. We've got 7.2 centimeters, 8.4 centimeters, and we've got 18 centimeters here for some of the dimensions, and we have to work out the volume of the prism to 3 significant figures. Well, what we'll do to begin with is we'll concentrate on this right-angled triangle. So I've got this right-angled triangle, but the problem is I don't know the base length, which is x, and I can find out what x is using Pythagoras. And if we were to use Pythagoras, then with Pythagoras, we have x then squared plus 7.2 squared equals 8.4 squared. So x squared, that's equal to 8.4 squared subtract 7.2 squared, which is 18.72, which means the length of x is equal to the positive square root of this, which is 4.326, etc. So this length here, we've got 4.326, etc. centimeters. Now what we need to do is find out the volume. Well, to find the volume, I need to find out the cross-sectional area and multiply that by the length. So if we find out the cross-sectional area, that's equal to, well, I've got the area of a triangle, so I've got 1/2 times by the base, which I've just worked out to be 4.326, and then I times this by the height, which is 7.2. So working out the cross-sectional area, I've got 1/2 times by this times by 7.2, which is equal to 15.57, etc. centimeters squared. And so therefore, to find out the volume, that's equal to this cross-sectional area of 15.57, etc. times by the 18, and this 18 is this length. So if I work out the volume, I'm going to times this by 18, and it turns out we get 280.36, etc. centimeters squared. So we want to round this to 3 significant figures, so we have 280 centimeters squared given to 3 significant figures.